Okay, angle bisectors 4-3. Writing this down with me. Angle bisector theorem. We dealt with the perpendicular bisector theorem yesterday. Today is the angle bisector theorem. Okay. What? Oh, no, not as much. Okay, guys, I want to show you really quick what it's going to look like. I'm going to write the words here and the picture there. So leave it space on your paper. So my image is going to go over here. So draw a nice good size angle made from those two rays. I'm going to call this B, this A, and this C. Ray BA and ray BC makes angle ABC. Everybody have that? Okay, what is an angle bisector? An angle bisector is a segment that bisects the what? Okay, now do the best you can. We're not going to take tools out, but do the best you can to make an angle bisector. See, that doesn't look very nice. The best you can to make it so it bisects. All right, everybody have it?
Yeah. What?
And I'm going to call this point right here D. Okay, so what is the angle bisector? BD. BD bisects the angle ABC. Now, since I told you it is an angle bisector, what markings can I put in here? That congruent angle markings. Do you guys see that? Okay, are we ready? So here is what the theorem states. If a point is on a bisector of an angle, if a point is on a bisector of an angle, comma. Now, do you agree that right here, this is the bisector of the angle? What is the point that's on this bisector? D. Okay, so right now we're talking about point D. If a point on a bisector of an angle, if a point is on a bisector of an angle, then it is equidistant. We did that word yesterday. Equidistant, meaning equal in distance. It is equidistant from the sides of the angle. If a point is on a bisector of an angle, then it is equidistant from the sides of the angle. What does that mean? From point D to point C and D to A are going to be congruent. Now, when you measure lengths between points and lines, you don't just randomly draw any line. When you're measuring length, it's perpendicular. So you find this perpendicular line, you find this perpendicular line, and DC will always be congruent to DA. Then, what did we say? AD is congruent to CD. Okay, so when are these segments congruent? It's congruent to any point on the, what is this called? The angle bisector. Okay, we're ready? Okay, we're listening, guys. All right, instead of writing like we did yesterday with the whole lot of words, we're just going to put here the converse is also true. Please stop. The converse is also true. What does that mean? I'm going to explain what the converse is. The converse goes backwards. If you have this same picture, but no angle markings, so I'm going to cover them. They didn't give you the angle markings, but they gave you that those two are congruent. If those two angles or those two segments are congruent, what does it mean about this line? It does what to the angles? It bisects. It's an angle bisector. Got it? All right. One last piece before we start doing some examples where we're solving is the word incenter. Do you guys remember from yesterday's lesson? What we didn't deal with angle bisectors yesterday. What did we deal with yesterday? Perpendicular bisectors, yes? What did we call the point where the perpendicular bisectors all met up, where they were concurrent? Circumcenter. The one for the angle bisectors is called the incenter. All right. It is the point of the point of concurrency of the angle bisectors of the angles of a triangle. All right, I'm going to highlight incenter just because we're going to need to know that along with the circumcenter. There's still two more that we're going to learn throughout the week. And we're going to draw a quick picture. Okay, now this picture, this triangle, I'm going to make it where it does not look like an isosceles. It's okay that it is. Just want to make sure that you recognize it does not have to be. Okay, do the best you can to draw your triangle. Everybody have their triangle? We're paying attention. Thank you. Okay, now, can one of you guys nudge him, please?
Wake up, sweet pea.
Head up off the desk, please. All right, so, guys, now, in the past, we would take out our tools and make them. Let me show you. This right here would be, we would have taken out our compasses. All those little pencil markings, like those X markings, are all the little things we would have been doing. Perpendicular bisector, and it makes the circumcenter. Okay, next one. We're not going to do this anymore, but I just want to show you what it would look like. All those little pencil markings and the X markings are using the compass. These are the angle bisectors, and when they all intersect, it's called the what? Incenter. These are the ones we're going to be doing later in the week, again, without the tools. Okay, so, listening. We're not going to do all that hard stuff. I hate to use the word fake it, but we're going to fake it. So do the best angle bisector that you can do. Just connect it or make it like that. I'm going to turn my paper. Now, again, angle bisector means you're doing what to the angle? Cutting it in half. All right, so I'm just turning my triangle around, and I'm doing the best I can to make angle bisectors. Because they are angle bisectors, is it safe to put those little congruent markings in?
Yes.
And then 2 on this one, and how many on the third one? 3. Shh, gentlemen. Okay. Do you see the triangle? Do you see the angle bisectors? Angle cut in half, angle cut in half, angle cut in half. Notice I don't put any tick markings here on the side because they're not medians or bisectors of the sides. It's bisectors of the angles. What is this guy right there called again? Incenter. Okay, now, like I told you yesterday, you will not be asked on the test what is the in-center, and then you have to come up with this definition. You don't have to match it that way, but what you will be asked to do, see if I can find that paper, is this. Do you remember I showed this to you guys yesterday?
Oh, yeah.
And then yesterday we looked for perpendicular bisector, the circumcenter. And did we all agree that this picture matched the perpendicular bisector? Ladies? Okay. Today we're dealing, what's the new one that we just learned? In-center, which is made up of the what? So look here. Take out C because we already used that one. There's only one here that has angle markings, not side markings, but angle markings. Which one is it? B? D. Do you agree that's an angle bisector, that's an angle bisector, and that's an angle bisector?
Yeah.
So what would D be called? In-center. So in-center would be letter D. Does that make sense? All right. Questions before we move on and solve for X? Okay.
So are those questions in the text?
These questions right here, yes, it'll be just like this. And we're going to review it more and more as we go. Okay. Examples. Number 1, find FB. With no marking at the top, are you writing stuff down? With no marking at the top, this is the same as saying find the length of FB. Without writing out the length, that's what this means. FB with no mark at the top means the length of. Find the length of FB. Okay, let's draw a picture. That's point C. We're going to make our angle. And we're going to draw an angle bisector. Now, because I'm telling you it's an angle bisector, is it safe to put those markings in there like that? They're either going to say it's an angle bisector, or they're going to put markings in, or they'll tell you the two angles are congruent. Okay. Put these markings in. This is B. This is D. This is F. Okay. According to these markings, what is CF called? CF is the what? It's the angle bisector of angle BCD. Do you guys agree? Okay. Now I'm going to give you this 6x minus 3 for BF or FB and 4x plus 9 for FD. Now that's all your picture is going to look like. Did they give you, were you given tick marks on FB and FD?
No.
No. So if the kid did not know the angle bisector theorem, can they just say those two are congruent? No, because there's no markings there given to you. But now that we know the angle bisector theorem, what do we know about any point that's on the bisector of the angle? It is what? Equidistance from the sides. So is F a point on the angle bisector?
Yeah.
So what can I say about FB and FD?
They're the same.
They are the same. So can we ourselves put those tick marks in? They will not be given to you when you're doing the worksheet. Will you have to put them in there on your own?
Yeah.
Yes, and I want to see those tick marks. That's part of you showing your work. So what can I say about 6x minus 3? It equals 4x plus 9. Go ahead and solve that now. Get your heads up off the desk and get to work. Oh, good grief. All right, let's go.
Good job. Oh my God.
You don't have to be mean to guys.
All right. Did you guys say thank you? Did you get it? What did you get for X? Okay. All right. Shh. Guys, X is 6. Now, first off, do I need to show that work or you guys have got it? You got it? Okay. Now, I heard what? I heard a few of you say, but that's not the answer, which is correct. So on the test, if this was the answer column and you put 6, would you get it wrong? Yes. Tell me why, Raymond. Because they're asking us for the length of what? FB. So he's right. You have to plug it in. What does FB equal? 6x minus 3. And what do you plug in for the x? 6. What's 6 times 6? 36 minus 3. So FB is 33. Do you agree?
Yeah, you can plug it into any one of them. Right?
Good job. Do you guys agree? He said because they're equal, if you wanted, could you plug it in for FD? What's 4 times... You're right. What's 4 times 6? 24 plus 9? Does it come out the same? All right. Question. All right. Number 2. Okay, draw this picture with me. Oh, let me give you what I want you to find. Find the measure of angle, KHL. Please stop the talking. Write this down with me. The measure of angle, FHL. And the measure of angle, KHF. Okay, there's 3 parts. Okay, draw your triangle. Well, not a triangle yet. Draw this first. Don't connect them yet. Just draw it like this. I'm going to make an angle bisector. Well, actually, I'm not going to tell you it's an angle bisector. Make what looks like an angle bisector. And then we're going to connect this to this. Now, again, mine's not drawn to scale. They'll look better on your worksheets. Okay, this is H. This is K. This is F. And this is L. And the only, oh, no, I'm not going to give that to you yet. The only markings I'm going to give you that's perpendicular and that KL is congruent to FL. That's all the only markings I'm going to give you. Okay, I'm going to tell you that this angle in here is 6y degrees. And this angle in here is 4y plus blank, and I'm purposely not giving it to you yet because I want you paying attention and not working ahead. Okay. Now, I told you when you draw this, draw what looks like a perpendicular or an angle bisector. So, according to the markings, there's no markings there. Can we say that's an angle bisector? Not yet. Can we say it just by looking at a quick glance? No, because the angle markings are not there. Do you agree? Okay. I'm going to do this in pencil because I am going to erase. So if you're doing it, do it in pencil or just wait. Do you agree this is the way we're used to seeing it? Big arrows or rays and rays like that. Yes? Okay. So this is similar to this image here. Only thing is they didn't extend those pieces. Is it still the same type of problem? Yes. Okay. So because we're using the converse of the angle bisector theorem, are these 2 segments congruent according to my markings? Which means that L lies on the what? The what? The angle bisector. That's the converse. If these 2 are congruent, then this is the angle bisector. So again, are these 2 congruent? So what does that mean about HL? It's called the what? Angle bisector. So did they give us those markings? Using the converse to the angle bisector theorem, can we say those are congruent?
Yeah.
Yes. All right, so this is 4y plus 18. What can I say about these 2 angles? They are equal. 6y equals 4y plus 18. Can you guys go ahead and solve that right now? Quickly. Mendoza, you as well, please. Stop playing with your hair. All right, solve and solve. Y equals 9. Do you guys agree? Okay, I need you guys to stop. And then they want us to find the measure of angle KHL. KHL is here. What expression do I have in angle KHL? 6y, and y equals what? 9. So plug in 9. What is the measure of angle KHL equal? 54 degrees. Okay. What's the other angle they want me to find? I found that one. What's the next one? FHL. What expression is in corner FHL? 4y plus 18? Yes or no? And what do I plug in? What do I plug in for y? And what's 4 times 9? 36 plus 18. What's the measure of angle FHL equal? Now that's kind of a double checker. Should these come out to be the same?
Yeah.
Yeah, so technically if you find one, do you know the other? Why do we plug it in? This is a way for us to what? Check. To check to make sure we've done it correctly. All right, what's the last one they ask us for?
KHF.
KHF. Is that the two of them combined?
Yes.
Yes. So you can do 6y plus 4y plus 18, or simply say it's 54 plus what? 54 plus 54. So what is the measure of angle KHF? 108 degrees. Any questions? Does it make sense? Okay. So you guys know what your assignment is tonight? Yes or no? Yes. Which ones were you doing again? Numbers 1 through 14. Thank you.